And a very good morning, everyone.
وعليكم السلام.
Can you hear my voice clearly?
Clear madam.
Okay, let's begin our class this morning for week 7. This is 7B class, our second slot for week 7. With recitement of doa. Volunteer, please.
الفاتحة. أمين أمين. بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين وعلى آله وصحبه أجمعين. اللهم افتح علينا حكمتك وانشر
Sekejap ya,
علينا من
saya tak boleh dengar suara you all.
اللهم افتح علينا حكمتك وانشر علينا من خزائن رحمتك يا أرحم الراحمين. رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي. رب اشرح لنا صدورنا ويسر لنا أمورنا واحلل عقدة من ألسنتنا تفقهوا أقوالنا. ربنا ظلمنا أنفسنا وإن لم تغفر لنا وترحمنا لنكونن من الخاسرين. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. وصلى الله على سيدنا محمد وعلى آله وصحبه وبارك وسلم والحمد لله رب العالمين.
Amin ya Rabbal Alamin. Thank you, Aiman Haris. Okay, so today we'll continue on the frequency response technique through gain adjustment design. Before we start our lead or lag compensator design. So after we finish this lecture today, we'll straight away try the previous final assessment question, which is from the latest February 2022, which the first question, which is question 2A, is for the gain adjustment transient response design. Okay, so so far, any question from the board plotting last week? Ada soalan tak? Okay, with the two rulers technique for board plot? Okay ke?
Okay madam.
Tak ada soalan? Okay. Okay,
Tak ada, madam.
thank you. So today, please ready with another new semi-log graph paper, because from the previous February 2022 question 2A, will sketch another board plot for the question which is related to gain adjustment, which previous semester student not a majority students can answer that gain adjustment question. So today I'll help you how to answer the gain adjustment question, because I assume that most of the students focusing on the lead compensator design or lag compensator design rather than focusing together with the gain adjustment design. So today we'll focus only on gain adjustment. Okay, so for this one, we already learn on the concept and technique of board frequency responses. We have discussed on the 10 frequency response theories, on the board plot sketching for magnitude and table, how to fill up the board table for magnitude and phase, and we analyze the board plot based on the gain crossover frequency, gain margin, phase margin, and the stability of the system. If the question didn't ask you on the stability analysis, you do not have to do that. Proceed with the next question, which is the design question. Okay. So this topic of frequency response technique is related to course outcome number 2, analyze the performance. and stability of the system. This one using frequency response, and it is CO2 is related to program outcomes number 2, which is identify, formulate research literature and analyze complex electrical engineering problem. Okay, so gain adjustment is the simplest compensator technique compared to the lead compensator, lag compensator, or for student 1 system ESC542, they need to use a hybrid compensator, lead and lag compensator at one time. Okay, for the gain adjustment, we vary the gain K. Some gain K given in the question, some gain K given by yourself, as we decide based on our previous question for the last week board plot sketching. That one is actually from previous final assessment question. That transfer function is from previous final assessment question, and that one the gain K is not given in the question, so we decide based on our target to have our constant at the numerator equal to 1. You can also decide other value that you want for your numerator. By deciding the value of the constant, you can determine your unknown gain K if the gain K is not given in the question. Okay, so this one, based on the gain adjustment, you need to determine, it is actually based on the gain and phase margin value. The phase margin value actually you can determine based on the percent of overshoot given in the question. From the percent of overshoot, you need to determine your damping ratio zeta. From the damping ratio, there will be another formula to determine the required phase. That required phase you can use to determine the phase margin. So based on this phase margin, you can decide how many gain adjustment, how many gain margin that you need to adjust, and based on the gain margin adjustment, then you can determine the new gain K. So that one is under this topic, gain adjustment designed for frequency response. Okay, so this is the formula that you need to use for gain adjustment. Firstly, of course, most of the question will give you the value of percent of overshoot. And sometimes the question will give you directly the value of damping ratio zeta. But if you are not given the value of damping ratio zeta, you can determine from the given percent of overshoot. Make sure you use this formula correctly. You know how to use this formula in your calculator. You know how to plug in your value of percent of overshoot in this formula, and make sure you get the correct value of damping ratio. From this damping ratio, you can use it to determine your required phase. Okay, so please be careful. At the denominator of the formula required phase, there is a double square root function. So please be careful. Make sure you can determine this required phase correctly, because some students, when they deal with the complex formula, they get confused. They'll tend to use the formula wrongly in the calculator. So be careful. So once you have percent overshoot, first determine your damping ratio, and then second, you can determine your required phase. This is for gain adjustment. Okay, based on the transfer function given in the question, first you need to plot your dot plot for magnitude and phase. Okay, for magnitude and phase, after you determine, after you sketch the dot plot, then you back to this formula, where you need to determine your required phase margin. This is important. Okay, this is important. Please familiarize yourself with this formula of required phase. Previously, you have the formula to determine the damping ratio from the percent of overshoot. Then you use the damping ratio value to determine the required phase. Okay, so okay, so this is your the black one is the magnitude plot on the upper one, and at the bottom one is your phase plot. Okay, so based on this one, okay, you can determine your phase margin. I'll share the formula later when I share when we try to discuss the example question, not the past year exam question, the example question. I'll share with you the formula, the step by step, the procedure, how to calculate until you determine the adjusted gain K through the gain adjustment for frequency response technique. Okay, so this is your dot plot for magnitude and phase. Okay, based on the required phase, you need to determine your phase margin. Okay, the required phase margin or desired phase margin. And based on this one, you need to determine the frequency at the required phase margin or desired phase margin. So first step, determine the damping ratio from the percent of overshoot. Second step, you determine the required phase margin. Third step, you determine your phi m from the phase plot. And at the phi m, you need to determine what is the frequency at your desired phase margin or required phase margin. And at the same frequency, you go to your magnitude plot, you determine how many magnitude that you need to adjust. Okay, so this is the required increase in gain. This is step number 5. So from this one, you can determine your new gain based on the gain adjustment technique. Any questions so far? Ada soalan?
iya betul.
Okay. Draw the magnitude and phase. Determine the desired phase margin tadi saya dah explain. Okay. Determine, this one is from the uncompensated. Okay. You sketch your dot plot for uncompensated system. And then you determine the desired phase margin. First, using this formula. And then you need to determine this one. Okay. And step number 3, you locate your frequency at desired phase margin, which is this one. And then step number 4, okay, you go to at the same frequency of desired phase margin, you go to your magnitude plot and you locate how many required increase in gain. Okay. Okay, let's say, okay, the question, okay, this is the example that we want to discuss. This is from your textbook. The author is Norman S. Knight. Okay, so this is your open loop transfer function given a closed loop transfer function, closed loop block diagram given in the question. You need to use open loop transfer function. Okay, please bear in mind for frequency response technique, you need to use open loop transfer function, not closed loop transfer function. Okay, you can ignore this one. I'll guide you how to answer this question. Okay, to determine the value of gain K. Okay. Okay. So based on the previous question, okay, so this is your transfer function from the open loop, which is this is K. In this case, from the textbook, the author assumed that the K value is 3.6. 3.6 for the unknown gain K, and then you can plug in into the open loop transfer function. The open loop transfer function is this actually, 100K divided by S plus 36, S plus 100. Okay, if you change to this one, so you need to settle down this 36 multiply with 100, and then this one plus 1. For this one, if it is unknown gain, you can target to make it this one like to be 1. But in this case, the author of the book want to target your constant at numerator to be 0.1. You can decide by your own, because at the end, the answer is same. Okay, in this case, a previous question that we used the transfer function to plot the dot plot last week, we assume that the transfer function, the constant, the final constant of the numerator to be 1. But this time, we target to be 0.1. That's why the author used the unknown gain K to be equal 3.6. Are you clear about that? Why the author choose 3.6? Okay. Next, okay, once you decide your value of gain, okay, you can plug it at the numerator and you can start construct your Bode table. This time I did not share with you the construction of Bode table and Bode plot. You can try it by yourself since we have tried one question last week. And then you need to construct Bode table and sketch the Bode plot for this transfer function. Okay. From this time, I'll share you the steps after we sketch the Bode plot and proceed with the gain adjustment design for frequency response. Okay, so after you sketch your Bode plot, okay, you can start using the value given in the question, which is the first one is the value of percent of overshoot, 9.5%. Okay, so the damping ratio is 0.6. From the damping ratio, you can plug in the value of damping ratio in the formula to determine the required phase. Okay, try to calculate both of these formula. Make sure you got the correct damping ratio and required phase. Dapat tak sama 0.6 for damping ratio, 59.2 degree for required phase using your own calculator. Now, you get the same and correct answer. Dapat? Ada yang dapat nilai lain?
Tak dapat, Madam.
Dah dapat? Selain Aiman Haris? Okay, so make sure you know how to use this formula correctly in using your calculator. Okay, so after you calculate the value of damping ratio and required phase, okay, the next step is, okay, so this is how to determine the phi m that we have discussed in the lecture notes. Okay, so use this formula to determine your phi m. Okay, use this formula to determine your phi m. This is your required phase margin. Okay, so this is my answer of phi m. Negative 180 plus the required phase margin. My required phase margin is positive 59.2. So my phi m, my required phase margin is negative 120.8 degree. So based on the value of required phase margin negative 120.8 degree, I go to the phase plot. I locate the value of this one, negative 120.8 degree. And I need to determine my frequency at negative 120.8 degree. We check our lecture notes. Okay, we check our lecture notes. Okay, so in step number 2, after you determine your desired phase margin, so phi m is equal to negative 180 degree plus required phase. Okay, so this is required phase, this is desired phase margin. Okay, label as DPM, desired phase margin. Dalam lecture notes, dia panggil desired phase margin. This is required phase margin. Okay, so after you determine your phi m, desired phase margin, you locate at which point. Katalah sini ialah saya punya negative 120.8 degree. This one, if you want to locate this one, make sure you know your scaling. Okay, you are the one who set your scaling for y-axis for the face. Make sure you know how to locate that value of negative 120.8 degree. There are some students who do not, who can't locate the value of face, especially accurately from their y-axis scaling for the face. You are the one who set the y-axis scaling. Then you should know how to locate any values from the face plot, especially. Okay, so at that value of desired phase margin, you should determine what is the value of frequency. Okay, this is step number 3. Okay, you locate the crossover frequency or the desired phase margin frequency at negative 120.8. Okay, and at the same frequency of desired phase margin frequency, you go to the magnitude plot, and then you locate how many requirement in the gain increment. Okay, so the method is, okay, so in my case, from my board plot, saya tak share board plot for this example. You try by yourself. You dapat tak almost similar. My frequency at desired phase margin is 13.8 radian per second. So from this frequency, I refer to my magnitude plot and I determine what is the magnitude value at 13.8 radian per second. In my case, my magnitude at desired phase margin frequency is negative 43.8 dB. Okay. Next. Okay, this is the formula. Dalam lecture notes tak ada. Okay, this is the formula. Okay. Using this value of magnitude at phase margin, desired phase margin frequency. Okay, so the formula is this one. Negative. Okay, so formula negative, value dia ialah negative, so dia akan jadi positif. So positive 43.8 equal to 20 log K prime. Okay, guna dulu perkataan formula K prime. And then you determine the value of K prime. Then after you determine the value of K prime, you can use this formula. This is actually equal to K old. This one is K old yang kita decide tadi. 3.6 at the beginning of the question, at the beginning of the solution, multiply with K prime. This is the formula to determine the new gain K or adjusted gain K. Okay, so 3.6 is my old gain K that I used K equal to 3.6 to plot my board plot for magnitude and phase. So now I plug in the value of 3.6 in this formula, which is K new equal to K old divided by K prime. K prime is this one. So K old is 3.6, then this is my new adjusted gain K based on the required phase margin 59.2 degree. So now I plug in my new gain K in this transfer function. Okay. So if the next question of this example is to determine the range of K for stable system, if I'm not mistaken, check. Okay, check the range of gain K for system to be stable. Okay, since we already determined the value of our gain K is 557.64, so the range of gain K for the system to be stable is between K larger than 0, lesser than 557.64. This is the range for stable system. Any question?
Madam.
Yep.
Boleh tengok yang step tu tak, Madam?
Step 2. Okay.
Actually, tadi saya sebut tak dapat, Madam.
Oh, okay. Sorry. Sebab tadi
Mana?
speaker saya tak function. Okay, tak apa. Lepas ni kita try dengan final assessment question. Okay,
Alright.
required phase margin. Make sure you boleh try lagi sekali. Yang lain ada yang dapat tak? With the same formula, with the same value after you determine. You tak dapat yang mana, Aiman? Damping ratio ataupun required phase margin?
Required phase margin.
Squared phase margin. Okay, try plug in semula. Make sure you gonna add tangent Sekejap ya, saya tengok formula. Betul tak formula saya? Formula saya betul. Yang lain ada yang dapat?
Dapat.
Very good. Sebab saya dah guna ni beberapa sem ya. So insyaAllah betul.
Okay, dapat dah, Madam.
Dapat? Alhamdulillah. Yang lain ada yang masih tak dapat? Make sure you try sampai dapat sebab dia ada double square root kan?
Dapat, Madam, dapat.
Dapat 59.2 betul kan? Okay. So after this we want to try our final assessment from February 2022 question 2A. So are you ready? Okay, step number 2 ada lagi yang tak dapat? Okay, this is step number 3. So you need to follow this step step by step until you determine the magnitude at desired phase margin frequency. Okay, this is step number 3. This is step number 4. And then the final one, you need to determine your transfer function, your new transfer function using the new gain K. And the last one, if the question asks you to determine the range of stability, the range of a K for stable system. So are you ready to try previous question? Tak ada soalan gain adjustment? Okay, gain adjustment is not really challenging compared to lead and lag compensator. It's a simple technique. Tapi saya tak sangka ramai student tak boleh jawab last semester. Okay, saya sangat tak sangka. Ramai tak boleh jawab. Okay, so this is the question. This is from the latest final assessment February 2022 for question 2A using gain adjustment. Okay, mana nak tahu? Construct the Bode diagram for the adjusted gain K. Tapi sebenarnya dia minta you construct daripada uncompensated system first. Okay, for this one. Okay, based on this one, you already given the value of zeta damping ratio from this percent of overshoot. Siapa nak try verify the formula, determine the damping ratio using percent overshoot, you can try. From 20% overshoot, you should get the value of damping ratio 0.456. Okay, so at this stage, jangan kira dulu you punya required phase, tak perlu. You kena sketch dulu Bode plot sebab you akan determine using the value of 5M from the Bode plot. So you kena determine you punya phase, you kena determine, you need to sketch your Bode plot first. Okay, so from this one, okay, you determine your open loop transfer function first. Okay, so this is 500K. Oops. Divide by S plus 3, S plus 50. Biasakan susun you punya roots, pole ataupun zero from the lowest until the highest number. In this case, you have pole at origin, pole at -3 and pole at -50. Are you done with this one? Make sure first step, determine the open loop transfer function from the given block diagram is correct. Otherwise, you punya design habis semua. Salah. Okay, next, what you need to do? Next step. Nah, you kena buat cepat ni. Okay, so set sekarang 8.40 kan? Okay, so the next one, I hope you can follow me. Saya akan train you untuk jawab dengan cepat. So next one, you convert into this one. Soalan. Okay. Okay, now let's say. Okay, let's say I want to, okay, there's no value of K given in the question. Tak ada kan? Okay, so what you can do is you can target this one to be 1. In order for that value to be 1, K should be equal to, K kena bernilai berapa? Berapa nilai K sepatutnya kalau kita nak 0.3? Thank you, Ikwan. 0.3. You juga boleh buat kalau you nak target dia sebagai 0.1, K akan jadi, macam dalam example tadi, dia nak constant numerator, the final constant numerator to be 0.1. You boleh juga buat macam tu. You nak jadikan dia 1 boleh, 0.1 pun boleh. Kalau saya nak jadikan 0.1, berapa nilai K yang sepatutnya saya guna? (0.03). Thank you, Ikwan. Okay, tapi hari ni saya 0.03 sebab dia target final constant numerator 0.1. Tapi hari ni saya nak try lain. K dia saya nak constant numerator, saya nak jadikan 1, saya nak pakai K 0.3. Dia akan memberikan jawapan yang sama. Saya dah verify. Okay. Okay, now let's fill up our magnitude table first. Okay. So at this stage, make sure all the 10 theories of frequency response semua kepala. Kalau you jawab test and final assessment, at this stage you nak fill up the board table, you nak refer to your lecture notes, dia akan jadi lambat dan akan drag you. Okay, so you do not have a choice, make sure semua dah ada dalam kepala. Okay, so this is our magnitude table. Okay, so first for our constant, okay. So first factor and then starting point for dB, and then this is the cutoff frequency. So our first constant, if you use K equal to 0.3, our constant at numerator will be 1. So calculate 20 log 1. Berapa? Berapa 20 log 1? Zero. Thank you, Faiz. Okay, so starting dB for pole at origin. Berapa starting dB for pole at origin? Pole at origin, theory number 3. This one, theory number 1. Theory number 3, pole at origin. Pole, theory number 7. Pole, theory number
Positive 20.
pole at origin, theory number 3. Ada yang jawab soalan ke? Saya macam ada dengar suara. Is a positive 20. Starting point for pole. Theory number 7, 0, 0. So your total starting point for your magnitude plot for this one, if you choose K equal to 0.3, is positive 20. Okay. Okay. Our cutoff frequency, 3 and 50. That's why we need to arrange our frequency from lowest to the highest. Case, the question didn't state your starting point for Bode plot, then start at 0.1 and arrange your cutoff frequency from the lowest to the highest, 350. Okay, from theory number 1, you need to fill up the slope at the empty part of the table. Okay, from theory number 1, 20 log 1 is a constant. Theory number 1, the slope for magnitude is 0 for all frequency. Either you want to fill up 0 or you want to leave it blank pun boleh. Okay, kalau saya nak cepat dalam final and test, saya akan advise student, I will advise student to just leave it blank. Okay, for the second factor, which is pole at origin, the slope for magnitude for all frequency is negative 20. Okay, next one. Third factor, which is pole. Same goes to the fourth factor, which is pole from theory number 7. Okay, since the cutoff frequency is 3, larger than cutoff frequency, since it's pole, so the slope will be negative 20 dB. Single pole, negative 20 dB. Larger than 3, the slope will be negative 20. Lower than 3, the pole is 50. So larger than 50, the slope is 20. Lower than that, the slope is 0. So I calculate the total slope for each frequency range. I'm done with my magnitude table. That's it. Any question? You kena buat lebih cepat daripada ni. Okay. You need to fill up this table within 1 to 2 minutes. That's it. The next one, I want to fill up for my phase table. Okay, so to fill a magnitude table, okay, you need to fill up very quickly. Okay, so factor, starting degree, this is the frequency range and this is the ending degree. Okay, so you have the same one, 20 log 1 j omega sekejap ya. Okay, dia tutup saya punya OneNote. Tunggu je, saya buka balik. For the meantime, you can fill up your magnitude and phase table. Okay, so 20 log 1 j omega. Okay, now we decide the starting degree from the phase part. Okay, for constant theory number 1, the starting degree is 0. Okay, for the pole at origin, the starting degree is negative 90. For pole, theory number 7, 0, 0. So your starting phase plot will be at negative 90 degree. Now we decide our frequency range only for the factor that has cutoff frequency which is non-zero has frequency range, meaning that this one from 0.3 until 30. This one from 5 until 500. Okay, now arrange your frequency from the starting point and consider your minimum and maximum frequency range. Arrange in from the lowest until the highest number, 0.3, 5, 30, 500. Any questions so far? Okay, next, for the first factor, which is constant from theory number 1, the slope for phase is 0 for all frequency. Same goes for second factor, which is pole at origin. The slope for phase is 0 for all frequency. The third factor, which is pole, the frequency range is between 0.3 until 30. Only within this frequency range, there is non-zero slope. Since it is single pole, the slope is negative 45. So larger than 0.3, the slope is negative 45. Higher than 30, the slope is 0. So this one 0. Okay, lower than 0.3, the slope is 0. Okay, ataupun saya nak leave it blank. Any zero values in this table, saya nak leave it blank. Okay, the next factor, which is also pole from theory number 7, only within the frequency range, it has non-zero slope. So larger than 5, negative 55, lower than 500, negative 55. Higher than 500, the slope is 0. Lower than 5, the slope is 0. Now I calculate my total slope for phase plot. And the final part of this phase table, I need to fill up for the ending degree. Okay, I repeat the theory for the phase calculation for ending of the phase plot. For any constant, it will contribute 0 degree. For any single zero, it will contribute positive 90. For any double zero, it will contribute positive 180. For any single zero, it will contribute negative 90. This is single zero, single zero, single zero. So your ending point will be negative 270 degree. For any double pole, it will contribute negative 100 degree. Any questions so far? Since I've completed the board table. Ada soalan? Can you follow my style of completing this board table quickly? Boleh follow tak?
Boleh, madam.
You have to do it faster than me. You kena buat lebih cepat daripada saya. Ni saya sebab sambil explain. Sambil recall the 10 frequency response theories. Kalau dalam final dan test, you can do it faster than this one. Untuk sketch manual board plot. Tapi saya akan guna OneNote. You boleh guna teknik two rulers. Teknik hari tu kamera shoot daripada atas sekali saja. Kalau you tak faham, you boleh tengok balik video tu. Okay, so hari ni saya akan guna OneNote. Saya akan guna ruler ni. Okay, so you guna teknik yang saya ajar last week. So now first decide your scaling based on your sekejap ya. Okay, based on your table. Decide your x-axis scaling first. Okay, so I want to start my sketch at 0.1 radian per second. So the first number one is 0.1. Okay, the next is 1 and this is 10, 100 and 1000. So I need to label this x-axis scaling as omega radian per second. Okay, any graph that you have in your answer script or in your report, like report project, mini project, final year project, you need to label x-axis, y-axis. And kalau you present dalam bentuk report, dia kena ada tajuk graph ataupun figure. Okay, now I want to label the cutoff frequency from the magnitude table 3 and 50. Boleh follow? Next,
Boleh
I
kita
want to label the minimum and maximum frequency range from the phase table. So kita ada 0.3, kita ada 5, kita ada 30, kita ada 500. Okay, this time you boleh plot sampai habis. Nanti saya ajar teknik macam mana nak make sure, how to make sure that your phase plot ending accurately at negative 270 degree. Tak kurang, tak lebih. Okay. So are you done with the x-axis scaling? So please refer to your magnitude table and phase table. Label all the cutoff frequency, all the minimum and maximum from the frequency range. Beside you label the starting point 0.1, 1, 10, 100, 1000. Kalau you start daripada 1, 10, 100, 1000, 10,000, you ada. Okay. Kalau you start daripada 0.01, your maximum frequency will be 100. This one kita boleh plot sampai habis sebab kita punya maximum frequency range is 500 and our maximum x-axis scaling is 1000. Okay, next, after we label our x-axis scaling, we need to check our starting point for magnitude. Okay, kita kena check starting point for magnitude. In this case, positive 20. Okay, since this is again adjustment question, saya nak you tinggalkan some space at the top of the semilog graph paper. Jangan buat terlalu atas untuk positive 20. Kejap ya, 1, 2, 3. Okay, in this case, okay, saya label. Okay. 40. Okay, saya nak start dekat. Okay, saya buat 20 dekat sini. So this one 40. Kosong. Kalau you nak turunkan bawah lagi pun boleh. Okay, kalau you nak turunkan bawah lagi pun boleh. Setelah you nak buat atas tu ialah 60. Okay. 40, 20, kosong, negatif 20, negatif 40. Pun boleh macam ni. Okay, bila gain adjustment, you kena ada space untuk dia naik atas sikit dan turun bawah. Okay, and then kita check starting point for phase, negative 90, ending negative 270. So kalau kita start dekat 20, so negative 90 jangan buat sama level dengan starting point for magnitude plot. Kita cari lain. Okay. So untuk magnitude saya nak start dekat sini. Okay. So label this one. So set your y and axis scaling first. X-axis scaling for frequency, radian per second. The left side of the y-axis scaling is for magnitude in dB. The right side of the y-axis scaling is for phase in degree. Ada soalan? Sebelum kita start plotting. decade. Siapa yang dah ready, you boleh sketch you punya reference slope. Okay, reference slope for magnitude kita ada 3, -20, -40, -60. So you boleh sketch. You tak semestinya start daripada sini. You nak start daripada sini, you nak start dari sini boleh. Tapi selalunya saya suggest student buat dekat kosong. Okay, so make sure you buat dia for 1 decade. Okay, make sure you buat dia for 1 decade. Contoh macam ni. Okay, so untuk saya tak perlu buat reference slope sebab dalam OneNote ruler ni dah ada angle. So saya tahu for 22 degree, this is for -20 dB per decade. Lebih kurang lah. Okay. So you kena buat betul-betul. You punya reference slope. Okay, ni saya buat lebih kurang je. So this is, sorry saya nak pakai yang lain. So this is your -20 dB. Buat very thin line saja ya untuk you punya reference slope. Okay. Make sure it's for 1 decade. The value untuk Y betul -20. And then for you sketch, you need to sketch for 1 decade. Okay. You buat manual lagi senang sebenarnya. This is for -40 dB. And this is for -60 dB. Okay, and then you boleh guna 2 rulers technique. Make sure it is perpendicular to your first ruler. Okay, so dalam ni saya tak boleh tunjuk sebab dalam in OneNote it only has 1 ruler. So saya akan pakai based on angle. So for my -60 dB, 50 degree. For my -40 dB, it is 39 degree. For my -20 dB per decade, it is 22 degree. So this -20 dB you can use for 45 degree, but you buat scaling 20 dB dengan 45 degree sama kotak jumlah dia. -40 dB you can use for -90 degree per decade. So for phase table you hanya ada you only need 2 slope, -45 and -90. So start sketching from for the magnitude table. Starting at +20 from 0.1 until 3, the slope is -20 dB per decade. Okay, from 0.1 until 3, the slope is -20 dB per decade. So now you can use both of your ruler. Make sure you are referring to the correct -20 dB slope. Make sure the first ruler is referring to the -20 dB per decade slope accurately, and then take your second ruler, make it perpendicular to the first ruler, move it to the starting point of +20 dB, and move your first ruler to the point where you want to start your magnitude plot at 20 dB. At the frequency 0.1 radian per second. So the -20 dB per decade slope from 0.1 until 3. Okay, so this one saya nak guna pink for magnitude. So sampai 3. So saya akan start daripada 3 ke 0. Okay, so this is my first part of the magnitude plot. From 0.1 until 3 radian per second, the slope is -20 dB per decade. Next one. Okay, this is my referring your first ruler to the -40 dB per decade. Since I'm using OneNote, my -40 dB per decade is 39 degree. Okay, So starts at 3 until 50. Okay, start daripada 3 sampai 50. So you habiskan yang mana you boleh buat sahaja. Don't worry about dia tak habis ke apa, that's okay. Okay. So habiskan dekat 50, ni memang habis ngam-ngam sampai 50. So saya hanya boleh plot, kalau kita turunkan dia punya scaling, the highest one is 60, then kita hanya boleh plot sampai 50 sahaja. Using two slope, negative 20 dB, negative 40 dB. That's okay. Are you done with the magnitude plot? Okay, kita take a break 10 minutes. Siapa yang tak siap lagi magnitude plot, tolong habiskan. Siapa yang dah siap boleh take a break 10 minutes. After break, we continue on the phase plot. Thank you. Siapa ada soalan boleh tanya.
Okay, madam.
Okay, let's continue on our board plotting. I hope that every one of you have done with the magnitude plot from the magnitude table before we continue on the phase plot. Okay, so from the phase table, okay, the starting point is negative 90 degree and the slope is 0 degree per decade from 0.1 until 0.3. Zero slope mean straight horizontal line. Okay, so from 0.1, so make sure that this is okay. This is the scaling for this is the starting point, negative 90 degree per decade. Please remember that start your phase plot on the left side, even though that you label your y-axis scaling for the phase plot at the right side. Okay, now we want to label our phase plot. I use purple. Okay, from 0.1 until 0.3, the slope is 0 degree per decade. Okay, from 0.1 until 0.3, the slope is 0 degree per decade. Okay, next. From 0.3 until 5, the slope is negative 45 degree per decade. From 0.3 until 5, the slope is negative 45 degree per decade. Okay, so this refer to your negative 20 dB per decade, which is equal to negative 45 degree per decade. Okay, so my ruler is referring to the negative 45 degree per decade. From 0.3 until 5, the slope is negative 45 degree per decade. I will start at 5 and at 0.3. Okay, so that is my second part of the phase plot. Okay, I'm done with the second part of the phase plot. From 0.3 until 5, the slope is negative 45 degree per decade. So this is our first, this is our second. Now, the third one, saya nak buat yang ni. Okay, this is the tips so that your phase plot will start and ends at the accurate starting and ending point that we have calculated from the phase table. Okay, so from 500, larger than 500 radian per second, the slope is 0. Larger than 500 radian per second, the slope is 0. So kita nak buat yang ni. Okay, slope 0 means straight horizontal line. Larger than 500 radian per second, the slope is 0, ending at negative 270. So you buat the final part. Then you akan dapat start dekat negative 90, berakhir di negative 270 degree. You takkan lebih, you takkan kurang. So larger than 500, the slope is 0 degree per decade, ends at negative 270 degree. Okay, saya dah buat dah ending point saya. So this is my ending point. This is my starting point for phase. So kita akan plot dulu that part starting and ending. The rest you kena completekan the slope in between the starting and ending point to make sure that your starting point and ending point is accurate at based on our calculated value from phase table. So tak payah label ya. Next one, kita nak completekan kita punya table. Okay. And what you can do is, you boleh nak buat negative 90 degree, you boleh buat negative 45 degree. Saya pilih untuk buat negative 45 degree yang keempat. Okay, which is sama dengan this one. Okay, so this is my negative 45 degree per decade. So from 30 until 500, the slope is negative 45 degree per decade. From 30 until 500, saya nak buat yang keempat, which is negative 45 degree per decade from 30 until 500. Okay, saya ambil daripada 500 berhenti dekat 30. Okay, so from 30 until 500, the slope is negative 45 degree per decade. And the final part, from 5 until 30. From 5 until 30, the slope is negative 90 degree per decade. This one, you boleh sahaja untuk terus sambungkan kedua-dua line ni. You boleh terus sambungkan kedua-dua line ni. Okay. Ataupun siapa nak lebih tepat, dia boleh refer kepada slope negative 90 degree per decade. Dia ada error sikit. Okay, you boleh refer kepada slope you negative 90 degree per decade. You boleh guna two rulers technique. You boleh connect this one. Nak make sure betul tak? Agak-agak betul lah. Okay, kalau siapa tak nak, dia nak cepat dah tak ada masa, you boleh sambungkan saja. With the assumption, you punya starting point zero slope betul, ending point zero slope betul, kita punya second and fourth part negative 45 degree betul, then you boleh terus sambungkan. See, kalau you buat betul, dia akan bersambung. So this is my complete Bode plot, phase and magnitude plot. The phase plot starts accurately at negative 90 degree, ends at negative 270. Using the techniques that I've shared with you just now, make sure that your starting and ending point for phase plot is correct based on your calculated value from the phase table, and you have sketched your magnitude plot correctly. So this one you can label. This is phase, label dekat ujung sebab ujung-ujung ni kita jarang guna dia punya information. So this is the magnitude. Any question? Ada soalan tak? Siapa dah siap plot?
Dah, madam.
Very good. So tadi kita start 8.40 daripada kira construct the transfer function. Sekarang 9.24 tolak 10 minit break. So dalam 30 minit. Okay, kita selesaikan ni dalam 30 minit. So for your case, untuk final and test, you kena reduce lagi. Sampai you settle sketchboard plot, 20 minutes is the maximum. 15 minutes is the best. Okay, this one sebab sambil saya explain, sambil saya sketch. So untuk test dengan final, you do not need to explain to anyone. You can do it faster than me. You should do it faster than me. Okay, now kita kena start design using gain adjustment. Okay, macam mana nak tahu soalan ni menggunakan gain adjustment? Nampak soalan terakhir. Construct the Bode diagram for the adjusted gain K. So this one, the first one, you guna ni from the uncompensated open loop transfer function. Yang kita dah buat tadi, first step, uncompensated transfer function, open loop transfer function, we already sketched the Bode plot. This is the second question. You need to construct the Bode diagram for the adjusted gain K, meaning that you need to use the gain adjustment technique. Okay, the gain adjustment technique, and then you need to determine the new gain K, determine the new open loop transfer function, determine the new starting point in dB. Then you need to sketch new magnitude plot. Yang akan berbeza ialah magnitude plot sebab you ada new gain K. This one. You ada new gain K, then you kena plot new magnitude plot for the adjusted gain. Okay, phase tetap sama. Phase dia tak akan berubah kalau you adjust gain. Okay, sebab starting point dia tetap kosong untuk any any values of the final numerator, final constant and numerator. The starting point will be equal to 0. So you punya starting point sama, negative 90 degree. Yang akan berubah bila you apply technique gain adjustment, yang akan berubah ialah this one. Okay, sebab nanti K you bukan lagi 0.3. You akan dapat nilai K yang baru. So let's calculate our new gain K. Okay. So please refer to this step. Okay, so we are done with step number 1. Kita dah buat dah step number 1. Kita dah ada board table, kita dah ada board plot. So now proceed with step number 2. In this case, you are given the damping ratio from the question 2A, February 2022. Damping ratio 0.456. Now calculate your required phase using this formula. 0.456, calculate your required phase. Okay, so proceed with step number 2. Given damping ratio is 0.456. No, now calculate your required phase. First time saya tuliskan semula you punya formula. 456 kan diberi. Okay, so divide by negative 2. Okay, calculate berapa required phase you. Boleh share jawapan dengan saya.
$48.15.
Very good. 48.15. Thank you, Gifari. Make sure you get the correct answer using this formula. Step number 3. Okay, you boleh refer you punya notes dari yang tadi tu. Okay, determine your desired phase margin. Sekejap ya, dekat saya ada blank page. Okay. Okay, so desired phase margin negative 180 degree plus required phase okay, use this formula, determine your desired phase margin from the calculated required phase margin negative 180 degree plus required phase margin. Dapat berapa?
Negative 131.85.
Negative 101. Point 5, betul tak?
85.
85. Okay, negative 131.85. Okay, now locate this value of desired phase margin from the phase plot. Okay, so now refer to your phase plot. Ni you tak payah tulis ni untuk note you saja. Refer to phase plot at desired phase margin negative 131.85. Cari nilai ni kat mana? Determine your frequency of your desired phase margin. Berapa radian per second? Okay, this one you kena tahu kat mana location negative 131.85 ataupun you nak assume negative 132 ke, negative 131.9 ke. So, kalau nak senang cerita, negative 100, you rounded negative 132 degree. Cari dekat mana nilai negative 132 degree from your phase plot, determine the frequency at this desired phase margin. You cari dekat you punya board plot, saya cari dekat saya punya. So you kena tahu scaling, kena make sure you kena tahu this one is 45 degree. You kena pandai-pandai locate. You yang buat scaling, you kena locate dekat mana. So mine will be okay. So kalau ni ada 10 kotak 45 degree, ni satu kotak ni is 4.5 degree. Okay, satu kotak ni, satu row ni is 4.5 degree. Okay, so you kena pandai-pandai locate kat mana. Saya akan locate saya punya. Okay, dekat phase plot ya. Somewhere around here. Okay, mine is somewhere around here. Okay, this is my 5M. You locate dekat mana you punya? Okay, so my frequency at this one is 2.7 radian per second. 7, 8, 9, 10. Saya punya 2.7. How about yours?
Sama, madam.
Sama. Okay. So this is my omega 5M. 2.7 radian per second. So you boleh fill up the answer. 2.7 radian per second. So tak lari sepatutnya, tak lari jauh lah. Siapa dapat 3 point something pun okay. Well done. Siapa yang dah dapat? Next step. Okay, at the same frequency. Okay, at the same frequency 2.7. Go to your magnitude plot. Okay, so magnitude plot. Berapa nilai magnitude? In this case, my case is negative 8. Negative 8.5 dB. Sorry, negative 9 dB. Mine is negative 9 dB. Okay, this is magnitude for desired phase margin. Label dia. Okay. So, saya punya negative 9 dB. Okay. Okay, this is step number 3. You determine your magnitude at omega at the frequency of the desired phase margin. Mine is negative 9 dB. How about yours?
Madam, if saya letak 8.2, okey tak?
Yep. Apa dia Gifari? Tak dengar.
Sebab saya punya line mengambil lah negative 8. So, if saya letak negative 8.2, okey tak?
Boleh. Boleh.
Okey.
Okay. Kalau untuk magnitude, okay, satu row ni ialah 2 dB. Okay. This one 2 dB. Sebab 10 kotak 20 dB. So satu kotak satu row 2 dB. Okay, done. Okay, next kita tengok step number 4. Okay, so done with step number 2, step number 3 sampai kita dapat the magnitude at desired phase margin. In my case, negative 9 dB. And then we proceed with step number 4. Okay, so use that formula, negative magnitude of desired phase margin equal to 20 log K prime. Okay, so this is step number 4. Negative of magnitude at desired phase margin is equal to 20 log K prime. So this is equal to negative 9 dB equal to 20 log K prime, and you need to determine what is the value of your K prime. Okay, in my case, it is 2.82. My K prime is 2.82. Dapat? This is actually, this K prime is actually equal to, oh sorry, not this one. Okay, K new is equal to K old multiply with K prime. In our case, K old kita tadi kita guna 0.3. This one, kita guna this one. So this is our old K. Okay, 0.3 multiply with 2.82. So this will be our new K. 0.85 is our new K. Jawapan untuk ni 0.9 something. Okay. Jawapan daripada answer script untuk final assessment 0.9. So that's okay. It's almost similar. So that is our new K. So sekarang the second question is to construct the board plot for adjusted gain K. So kita kena masukkan balik nilai new gain K ni dalam kita punya transfer function this one. Okay, so 500K, K tu kita kena pakai new gain K divide by 150. So we need to calculate our new transfer function using the new gain K. Okay, this is step number 5. Okay, 5. Okay, for step number 5, kita assume adjusted gain adjusted gain. So 500 multiply with new gain K. Okay, so this one S plus 30, S plus 3, S plus 50. Okay, so you multiply. Okay, now we convert to just gain in frequency domain. So 425 divided by 150. So your final numerator is 2.83. Your final constant at numerator is 2.83. So this one you need to calculate your new starting point. New starting point in dB for magnitude plot is 20 log 2.83. Which is extra 9 dB. Saya rounded extra 9 dB. So previous one, our starting point is 1. Our numerator is 1. Okay, our numerator is 1 and the starting point is 0 dB. So our new starting point, our new starting dB for 20 log 2.83 kan tadi. Okay, 2.83 9 dB. And then kita ada from pole at origin, the starting point is 20. Therefore, our new starting point is 9 dB. Not more 20 dB. 20 dB is for the old gain K where you use 0.3. For the new gain K, the total starting point for magnitude is 29 dB. So you kena plot sebab dia kata construct, soalan minta construct the Bode diagram for the adjusted gain K. Untuk phase tak perlu construct, you hanya construct untuk magnitude saja. So with the same slope, slope sama. Using the same slope, negative 20, negative 40, negative 60. dB per decade from 0.1 until 50 and larger. So starting point dekat 29 dB. Cara dia ialah, okay, so you locate you punya 29 dB. Saya padam this one. Okay, so 30, 29 dekat sini. Okay, 29 dekat sini saya pakai orange. Okay, so using the same slope, you parallelkan dengan this one. Okay, so this is negative 20 dB. So you naikkan atas, dia akan start dekat 29 dB. So sampai dekat sini negative 20 dB per decade. Okay. And then this one kita ambil reference slope yang ni at 3 until 500. Sorry, until 50. The slope is negative 40 dB per decade. You can sketch lagi untuk 60 dB. Tadi kita tak sketch sebab tak habis. Okay. So kita habiskan untuk larger than 50 dB, 50 radian per second. The slope is negative 60 dB per decade. So the orange one is the adjusted gain for the magnitude plot. Okay, so you boleh label this one. You nak label macam ni pun boleh, adjusted. Okay, dia ada markah untuk you plot magnitude plot for adjusted gain. Yang ni memang tak ramai student tak jawab part ni. Dia tak tentukan nilai new gain K, dia tak plot adjusted gain magnitude plot. So ada banyak missing marks dekat situ. Ada soalan? That's it for our class today. Tak ada soalan? Sure?
Tak ada soalan, Madam.
Faham untuk gain adjustment? Please follow
Faham.
these steps. Okay. Step number 2, start selepas you habis sketch board plot. This is step number 1. Okay, saya label Okay, so this is step number 1. Step number 1, you need to determine your open loop transfer function, convert to frequency domain, then construct your magnitude and phase table for board plot, and then start sketching your board plot for magnitude and phase. And then step number 2, start calculate your required phase based on the damping ratio. If the question gives you the percent of overshoot only, you determine the damping ratio first and then determine the required phase margin, the required phase. Based on this formula, be careful when you use this formula using your calculator, make sure you calculate correctly. And step number 3, you determine your desired phase margin using this formula and locate the coordinate of the angle and determine the frequency at the desired phase margin. At the same frequency, go to the magnitude plot and determine your magnitude at the desired phase margin, in this case negative 9 dB. And step number 4, using this technique, using this formula, you determine your K prime, and then you determine your new gain K using this formula, where the new gain K is equal to the K old. K old is the K that you use for the uncompensated board plot at the step number 1, multiply with K prime, in this case 2.82, and this is your new gain K 0.85. And step number 5, you need to determine your new transfer function from the adjusted gain K, and you convert into frequency domain, and you have nominal constant at the numerator. Since you have new constant at numerator, meaning that you need to calculate your new starting point in dB. So this one you need to plus with the starting point contributed by the pole at origin. So new starting point will be 29 dB for adjusted gain. Okay. Then you need to sketch, sebab soalan minta construct the board plot for the adjusted gain K. So bila construct for adjusted gain K, phase plot will be same as the previous old gain 0.3, but only the magnitude plot will be a new one, since you have a new starting point at positive 29 dB. The slope will be equal between the frequency, the starting frequency and all the cutoff frequency. And that's it for today. Ada soalan? Last call. Tak ada? Okay, so this is from question 2A February 2022. So next week, please get ready. Kita akan masuk lag compensator dulu, week 8. And then selepas week 8, kita akan cuti seminggu untuk perayaan Gawai. So Jun, 6 Jun, first day of week 9, cuti the birthday of Yang di-Pertuan Agong. So you akan miss lagi kelas untuk hari Isnin week 9. Saya akan jumpa you kelas hari Rabu 8 pagi 8 Jun with the lag compensator. Boleh? So week 9 hari Isnin cuti birthday Yang di-Pertuan Agong. You ada lagi satu cuti hari Isnin week 14 hari raya haji, hari raya korban. Hari raya korban 10 Julai hari Ahad. So kita replacement leave hari Isnin. So you ada 2 lagi cuti hari Isnin. So kita kena kejar untuk kelas yang banyak cuti hari Isnin. Untuk sebelum kita masuk lag compensator, saya akan bagi video untuk lag compensator. So untuk kelas hari Rabu, kita akan terus start buat satu soalan lag compensator daripada previous final assessment. Setuju? Okay, you tengok dulu lecture notes untuk lag compensator. Saya dah sediakan sama juga macam gain adjustment tadi, step by step. So you akan follow that step by step. You tengok lecture notes, you tengok lecture recorded lecture video. Saya akan bagi link kat YouTube. So by the time 8 Jun, kelas week 9 hari Rabu, kita akan start buat lag compensator question. Kalau tak, kita takkan sempat try few question for each. Design, gate adjustment, lag compensator, lead compensator. Boleh? Setuju tak? Okay.
Setuju.
Okay, Bode.
Please don't forget to sign your attendance. For the missing previous attendance, please message me if you want me to verify on behalf of yourself. Saya boleh verify you punya attendance untuk previous. You tak boleh dah sign attendance untuk previous class. So let me know by today 12 noon. Siapa yang less than 80% attendance, saya akan keluarkan first warning letter. That's all for today. If there's no question, see you next week. Untuk kelas hari Isnin depan tak cuti, 23 Mei kita akan jumpa untuk lag compensator. We end our class with tasbih kafarah surah wal as. Okay, Assalamualaikum. Thank you very much.
Waalaikumsalam, Madam. Thank you, Madam.
Thank you, Madam.